Guys, how's it going? Today we are going to talk about redox reactions. Specifically, my goal for today is to learn how to write half reactions for the oxidation half and the reduction half of the reaction. Our last video involved assigning oxidation numbers, and that is going to come in helpful for today for knowing what is being oxidized and what is being reduced. So let's get right to it. Okay, so ultimately, to understand how to write the half reactions, we really need to know the vocabulary well for this unit. So I have this cute little picture of my friend Leo here. Leo's a lion, and he is obviously saying grr, because, you know, he wants you to he wants you to be great. There we go, grr, great. Or he wants to eat you. I don't know, it could go either way. So Leo here, it stands for lose electrons oxidation, and GR stands for gain electrons reduction. So this is just a kind of mnemonic to remember that whatever is losing electrons is oxidized and whatever is gaining electrons is reduced. So when in doubt, Leo says GR. Okay, so what does that actually look like for the oxidation numbers? Well, if you are gaining electrons, the reason why it's called reduction, despite that seeming awkward, like you're gaining something and yet it's being reduced, the reason why gaining electrons goes with reduction is because if you're gaining a negative electron, your oxidation number is going to go down because you're gaining something negative. So the oxidation number is reducing, going more negative. And if you're the thing being oxidized, you're losing electrons and your oxidation number is getting more positive. So reduction, gain in electrons, decrease in oxidation number. Oxidation, lose electrons and your oxidation number increases. Now, this vocabulary gets a little bit more complicated when we talk about the agent of it. So if you have a species which is oxidized, it can also be called the reducing agent. Now, that may seem weird, but let me give you some background to it. So basically, if you are losing electrons, then you are forcing your electrons to be with another element. You're like, listen, I don't want these things, they're negative, so I'm going to give it to you so you can be negative, okay? And so ultimately, you are making something else reduce, so you are effectively like the reducing agent, even though you're being oxidized. The same goes for the reverse. So if you are the species which is reduced, let's say you are the thing that is gaining electrons, then you are taking electrons from another element. So you are oxidizing it because you're stealing its electrons. So I am not going to focus too much on the agent vocabulary because I feel like it's already confusing enough with the fact that you're gaining electrons and you're going down in number, and you're losing electrons and you're going up in number. But there may be 1 or 2 questions on your test about it, so it is good to know. Okay, so let's look at a chemical reaction. We've actually already seen this before. Silver nitrate reacts with copper. It is a single replacement reaction, which means that copper and silver are just going to switch places, and so you form copper nitrate and silver. Remember, I had like the little squiggle in the test tube and it formed all like the silver on the outside. The reason why the test tube had like a bluish tint to it is because copper in solution looks blue. So this is the reaction that's happening. Don't mind the fact that there is no arrow here. That's just like a formatting error for my PowerPoint. And we are going to break down this reaction. In another video, I go through how I assigned oxidation numbers to all of these species, but for now we are just going to show what they are. Okay, So oxidation is the loss of electrons, and an increase in the oxidation number indicates an atom has lost electrons and is therefore oxidized. So which reactant with an increase in oxidation number? Identify the species with an increase in oxidation number. So what is oxidized? What is increasing its oxidation number because it's losing negative electrons? Well, let's take a look at what we have here. If we have silver, that's +1, silver goes to 0. So it went down. So it can't be that because it's being reduced. It's going down. Nitrogen stays the same, so nothing's happening. Oh, shoot. I showed you the answer. Sorry. Nitrogen's not changing, so nothing is happening with that. Oxygen's not changing, nothing happening there. Copper is going from 0 to +2. So it is being oxidized because it is losing electrons. Leo, lose electrons, oxidation. And again, electrons are negative. The more negative things in your life you lose, the more positive you become. So copper is the reactant that is being oxidized. How many electrons were lost? Well, it goes from 0 to +2. So it lost 2 electrons. Which species reactant was oxidized? Well, it was copper that was oxidized, so we already said that. Write an oxidation half reaction. Okay, so for half reactions, you're pretty much just going to ignore everything other than copper. And so how it looks is here you have copper. My arrow got messed up again. This is supposed to be an arrow. You have copper that is oxidation state of 0, and then it's going to form copper +2. So this is reactants, and then on the other side of the arrow are our products. Now, when it does so, it is losing 2 electrons. Now, the reason why I wrote 2 electrons on the product side is because if you look at the charges here, +2 and 2 minus cancel each other out to make 0. So you can also think of this arrow as an equal sign, and you need the charges on the left side to equal the charges on the right side. So overall, I know that this is what my oxidation half reaction looks like. This is just showing me the oxidation side of the reaction. And I know oxidation involves losing electrons. If this is easier for you, you can just memorize this, that the thing being oxidized, when you write the half reaction, the electrons will be on the product side because they are losing those electrons. Okay, let's try the reduction side. Identify the species with a decrease in oxidation number. So we already said nitrogen staying the same, copper is being oxidized, can't be copper. Silver, however, is going from +1 to 0. So it is the thing decreasing in oxidation number. So on the reactant side, silver is represented as aqueous. So we're writing silver aqueous. How many electrons were gained? Well, it goes from +1 to 0. So only 1 electron was gained. Sorry, it was silver +1. The reason why we write +1 is because it is a positive ion based on its oxidation number. Which species reactant was reduced? Again, silver ion is the thing being reduced. Write a reduction half reaction. So again, we have silver ion that is on the left side. So we have our Ag. We're ignoring all the other things. Notice how nothing else, no nitrogen, oxygen, copper is in the half reaction. It's only the silver. So we have our silver, Ag +1. I know it's +1 because I solved for the oxidation number, which again, I'll show you a video of how I did that separately. It's aqueous, which means it's in ion form, so it has this charge. And now, because it's being reduced, it's gaining an electron. So this +1 electron is on the reactant side because it's gaining it. And this should be an arrow, same as before. I don't know why none of my arrows turned out, but this goes to neutral silver, which is on the product side. Notice again how the Ag plus 1 plus 1 negative electron, the positive and the negative charge here, cancels out to form 0. So this equation makes sense charge-wise. Okay. So we have a problem though, because if you see here for the reduction side, we're only gaining 1 electron. But on the previous slide for the oxidation side, we are losing 2 electrons. So you can't have something losing 2 electrons and then the other thing only taking 1 of them. No. This is, you have to have mass be the same on both sides overall. You can't create or destroy matter. You also can't create or destroy charge. So we need to do some finagling here. Okay. So the way this is going to work, we multiply each half reaction by a factor to make the number of electrons gained in one half reaction equal to the number of electrons lost in the other, and then just add them together. So that sounds more complicated than it actually is. Let's just do it. So here we have copper. Again, the box represents an arrow. The copper solid reactant going to aqueous copper. And again, like I said, it is losing 2 electrons. And then here we have our reduction side where silver is only gaining 1 electron. So in order to make this so you can add these two together, you need 2 electrons on the product side to cancel out 2 electrons on the reactant side. The way we do it is just multiply this whole thing by 2. The whole thing gets multiplied by 2. So now you can distribute this to form 2 silver ions plus 2 electrons plus 2 silver solids. And when you do that, again, now that you have 2 electrons here, 2 electrons in the reactants cancels out 2 electrons in the products, and you have your overall reaction is just all the stuff you added together. Everything on the reactant side stays on the reactant side. So your copper ion and your copper solid and your silver ion, again there's 2 of them, goes on this same reactant side. And then your products, which are right of the box or arrow, would be copper plus 2, which is right here, and your silver solid, which is right here. Again, there's 2 of them because we distributed the 2. The last step is to balance the overall reaction. So by, so by doing that, we just bring back in the nitrate, the thing that was not involved at all in the reaction before. We bring it back in. So nitrate NO3 has a -1 charge, so it perfectly works with silver. So for every 1 silver, you have 1 NO3, and that makes a neutral compound. Copper, however, has the +2 charge here, so you're going to need 2 nitrates to make the charge work out for your copper nitrate. So notice how we put it in parentheses and then 2 nitrates. So this is now the overall chemical reaction. The nitrate, which is not oxidized or reduced, it's called a spectator ion. It's just kind of there hanging out in the background, but it doesn't actually do anything in the reaction. So yeah. Okay, we are going to do another practice problem. So in this problem, we have zinc reacting with hydrochloric acid to form zinc chloride and hydrogen. So to assign oxidation numbers to all the species, I'm going to just go through this quickly because I'm running out of time. I have, there we go. Zinc is neutral, hydrogen is +1, chlorine is -1. Here we have zinc is +2, and each chlorine is -1, and hydrogen is 0. So determine which species or reactant was oxidized. So who got more positive? Who is losing electrons? It looks like zinc got more positive. It went from 0 to +2. So zinc is the species being oxidized. Who is being reduced, or who's going down in oxidation number, getting more negative? That looks like it is hydrogen because it goes from +1 to 0. So